Hello, my name is Ben Zimmer from Enable Training and Consulting. We're the providers of lvmastery.com online LabVIEW training. What you're watching is the first of a series of introductory videos intended for the FIRST Robotics competitors, both the team members and the mentors. What we're going to present in these introductory videos are really a map of the landscape of LabVIEW. For most of you, you're using LabVIEW for the very first time. And I know that many of you don't even know what you don't know yet. So our goal in these videos is to help people who don't know where to start and don't know what to ask to get started within LabVIEW and then to navigate the multitude of resources that are out there on the web for them. Let's proceed now right into LabVIEW. When you first launch LabVIEW, you're presented with this screen, which is the Getting Started screen. You see there's several sections here: New, Open, and Resources. Let's focus first and talk about the Resources section. Within the Resources section, there's links to all kinds of important information, including how to get started in LabVIEW, the NI First community, a robotics programming guide. You can just click on any of these to launch them directly from this screen. Also, there's information on technical support. But most importantly, there's an examples section. We're going to spend some time going through one of these examples in particular. In the New section, you have the option to create a new blank VI, and a VI is just short for Virtual Instrument, which is a LabVIEW program. Or you can create a new FRC robot project or an FRC dashboard project. A robot project is the code that's going to run on your controller, and the dashboard project is the code that's going to run on your laptop or any other computer which is actually monitoring the robot. Also, you have the ability to open existing code, and you would see a history of previously opened VIs here. So let's go on into the example section. The example I want to open is not one of these four, so click on the More button to see the complete list. You're then presented with a complete list of examples, and the example I want to open is the joystick input example. The window that then opens is the Project Explorer. This is the main screen in which all of our VIs are organized. And also take a look here, we've got two sections under the Items tab: My Computer and the RT Compact Rio Target. If we expand the My Computer section, we see, although we have some categories here, there actually are no programs underneath the My Computer. However, on the RT Compact Rio Target example, we see that there actually is a program. This is the Joystick Input Example VI. This is actually the code that we're going to run and we're going to take a look at. The reason it sits under the Compact Rio Target section is because it's going to run on the Compact Rio Target. Later on, when you open up other programs, such as the dashboard example, you'll see that the programs which are going to run on your laptop or on your desktop computer will appear under the My Computer, and the code that's going to run on the real-time target is under this section. The first thing that we're going to do is right-click on the target, choose Properties, and change the IP address to match the controller that you've got set up. And remember, it uses your team number, Go Wildcats, in order to choose the appropriate IP address. So now that we've done that, let's open up this joystick input example and see what we got. So the first thing we see is this joystick input example VI front panel. So any piece of LabVIEW code contains two pieces. First, it contains the front panel, and if we go to the window menu, we can choose to show block diagram. These two pieces comprise any piece of LabVIEW code. The front panel is much like the front panel of any instrument. It contains all the knobs, buttons, indicators, and graphs. The block diagram contains all of the wires. So this is where the code resides, on the block diagram. So before we dive into and look at this code a little bit more, first thing we'll do is we'll actually run this program. And if you've got your controller configured properly, when you run it, it should deploy onto your hardware. It may take a few seconds for the hardware to properly deploy and to find the target, but once it's done, it should immediately start running. And once it's running, you'll see a dot on the screen. And if you were to move the joystick, which is attached to USB 1, you'll see as you move it, the dot on the graph will move, as well the two bar vertical and horizontal indicators will move as well. And when you click stop, the program stops. So congratulations, you've run your first LabVIEW program on your controller. Let's take a few minutes now and take a look at this code and maybe do some slight modifications so we can help understand what's actually going on here. So let's proceed first by taking a look at what we actually have sitting on our front panel. We see 1, 2, 3, 4, 5 different items on the screen. The first is the stop button. If we take a look also at our block diagram, we see there's something here called stop. The way LabVIEW code works is for every object on the front panel, there is a corresponding terminal on the block diagram. The objects on the front panel are called controls and indicators. The stop button is a control because it's something you push that you can modify. The graph, for example, is an indicator because it's something that the software modifies. In other words, controls are inputs and indicators are outputs. If you double-click on any of the controls, you'll see that automatically the matching terminal is indicated on the block diagram. Before we go too much further, I want to show you exactly how I selected that item. From the View menu, choose Tools Palette. That's going to bring up this floating palette. You can move it around by clicking anywhere in the title bar. There's all kinds of items here, and at this point I just want to point out that the Automatic Tool Selector should be on. As long as the Automatic Tool Selector is on, then you notice that the tool changes depending on where your mouse is hovering. That's the most important point to understand about the Automatic Tool Selector. Depending on where your mouse is hovering, the action is different. For example, if you click in the middle of this control up here where the joystick port is, you get to choose what type of joystick port you have. However, if you click on the very edge, it's an arrow, and then you can click on it and move it around. You can also click undo to put things back. And like I did a moment ago, if you double click on the edge of an object, that will help you find its terminal. So we see that the stop button has a terminal. We see that the joystick port has a terminal. If I double click on the terminal, I also can find the control. Same with the graph and with these two indicator bars. I'd like also to take a second to point out something really useful, which is the context help. If you pull up the help menu and choose Show Context Help, then you have a little help window that you can move around by clicking and dragging in its title bar. Depending on what you hover over with your mouse, the context help changes what it tells you. It's one of the fastest ways to learn how to navigate within LabVIEW is to use the context help window. There's also a shortcut. If you push Ctrl-H, the context help will toggle between being shown and hidden. Let's look a little closer at this block diagram code. So we see we have our joystick port terminal here. We also have this block. Again, if I activate my context help, we see that this is actually a VI itself called open.vi. And there's some documentation provided here. This is what's called a SubVI. We mentioned before that any piece of LabVIEW code is called a VI, or virtual instrument. You can put VIs inside other VIs. And that's how we make modular code. And when we place a VI inside another VI, it's called a SubVI. So we see here we have the joystick open SubVI, and we have the joystick get SubVI. And then over here we have the joystick close. Think for a minute about how the joystick communications worked within this program that we just saw. First, the joystick would be opened, and then the joystick position was read over and over and over again. And then finally, when we're finished, the joystick would stop being read. And that's exactly what happens in this code. And the way that it happened over and over and over again is by this rounded gray box here. If we hover over it, context help will tell us that this is a while loop. So a while loop in LabVIEW is a way to get code to run over and over and over again. Essentially, a while loop will run until a condition is met. And that condition is indicated by this symbol here. So we see in the bottom right of our while loop, that loop condition is wired to our stop button. And that matches what we saw in the behavior, that we were continually measuring the joystick position until the stop button was pushed. So now that we understand that we're using SubVIs to communicate with the joystick, and that we're using a while loop to do it over and over again until the stop button is pushed, let's take a quick look at how the data is actually being put into the graph. You've probably noticed that there are different colored lines connecting up terminals such as our joystick port terminal and our joystick open SubVI.